and or you haven't been asking questions. So I don't think I've shut anybody down on any questions yet, have I? I don't think. Which hardly anybody asking questions. Did I shut you down? I didn't tell you I wasn't going to answer the question, did I? Oh, well, that was, yeah, that, you didn't have enough information on that problem to do it. So the point was to do the ones that were in that little box there. Yeah. Actually, I answered your email. I don't know how quick it was, but okay, so example 3.7 on page, what's this here? I don't care about that color. On page 43, let's look at that one. So we've got a picture. Let's see, let's write this down here. If we can. That big pointer. Okay, so example 3-7. Oh, it's not up on the screen?
No, he was asking if we could pull up what you're doing.
Oh, no, because I'm using my laptop and it's not hooked into that. Sorry.
What page are we on?
Page 43. So we've got something that looks like this. And this is the free body diagram, right? And we've got, now what I did on the homework problem, I went ahead and put what I thought was AY, mostly because I wanted to start thinking about there really is a reaction force at A, isn't there? Okay, they weren't asking us to solve for it, but eventually we will be. There's a reaction at A in the X direction, or could be. There may not be, but we have to think that there might be. Then we've got a force right here that is 3 kilonewtons, 3,000 newtons, right? And this distance right here is what, 5 meters? I started to write down 5 feet. Then we've got another force here that is 8 kilonewtons. Kilo, right? Not kill. Makes a difference, right? We don't want to kill any newtons. 7 meters. And we've got the old ever-dreaded, that's why this one's different. The ever-dreaded evenly distributed load. So we're going to have one force somewhere right here, probably right in the middle of that 14 meters. And it's 2 kilonewtons per meter over 14 meters. So, if you will, 2 kilonewtons per meter times 14 meters equals about 28, I didn't bring my calculator again, kilonewtons, right? Because the meters cancel out. So we'll have 28 kilonewtons. Now, it shows that to the very edge, to the left edge, what, Al? Do you have a question?
I was just looking at the book and thought, was that W equals 2 kilonewtons
Right. Weight 2 kilonewtons per meter.
per meter.
Yep.
And there's 14 meters.
So that's how you get to 28 kilonewtons.
Got it.
Okay, all right. Then what it shows you is, if you'll allow me to draw this little deal here, that evenly distributed load from here to there is 4 meters, right? And then there's 14 total. So that means this distance right here would be 7 meters, right?
Oh, to the center of it.
Right.
Yeah.
Because that's what you do is you make that a concentrated load right in the middle of that evenly distributed load. Okay? Then it also shows that we've got reaction at B. We've got a BY. Is that the last? Yeah, that's the last of the load, isn't it? So it's a pretty good educated guess that the reaction at B in the Y direction is up, because all these forces are pushing down, right? So more than likely both A and B are going to have to push back up. The reaction at B in the X is going to be 0 because it's on a roller. So that would be my free body diagram of this problem. So maybe it's, just as well that we don't have the picture, huh? It's going to have to be today. Normally I'll put those back up there. I just forgot. Okay, so, Brian.
Would you go ahead and add 7 or just a simple fire diagram?
Well, yeah, I would personally. The question is, would we add the 7 and the 4 meters here between the 8 kilonewtons and the 28? And yes, I would. In fact, what I normally like to do, if I've got these, I might put, and the problem, we're doing the moment relative to A. So I would put all of my dimensions from A. I've got 12 meters here, right? And this is how you'll see my solutions. And let's see, what do we got here? 12 and 4 is 16, and 3 would be about 23. Who needs a stinking calculator? That's one thing you got to watch me too. Sometimes I'll screw up on my addition. The simple things in life, I screw them up. There is one more dimension, isn't there? Well, no, it just says from here to there is 14, so that would mean that we'd have a dimension, and we're going to need this dimension eventually. Let's see, we got 23 plus 7, yes, 7, so that's 30 for the overall. We will need that eventually. We don't need it right now because all they want to know is they're actually looking for the resultant force in this, right? The resultant force. Where would the force be that if you add all 3 of those forces up, where would one force be that represents that? That's what this problem's looking for. And it's going to be, if you look in your book, it's going to be somewhere between these forces, isn't it? That's the way they're depicting it in the book. So they're saying there's one force that we could represent by R, and it's so many meters from the left side, if you will, or from A, and we can calculate that. And this is exactly like what we finished up with Friday, isn't it? Okay, now the one thing they do in this that I don't know, excuse me, I don't know that it's 100% necessary, is they go in and they figure out what each one of those moments is for each of those forces. I'm not going to do that. I'm just going to do, well, actually I do have to figure out, I do have to do this. I have to do the resultant magnitude is the summation. God, that looks like crap. Fix that. The summation of the forces in the Y, isn't it? Okay, so we had 3, and that's a negative, isn't it? 3 kilonewtons minus 8 kilonewtons minus 28, right? And that equals what? Let's see. 3 and 8 is about 11, isn't it? 39 kilonewtons down. Let's see if I'm right. Whew. Fortunately, I'm right. And in the book, they show negative 39 down. I just assumed it was just 39 down. You don't need that negative sign in there. That arrow down shows you that it's negative. Okay? That makes sense so far? That should be pretty easy really at this point. The only thing that's different there was the fact that you had to find that 28 kilonewtons and where it's located. That's the only thing that's different.
Why did you put that blank? Never mind. I understand now.
The 28?
Yeah, I thought it was at the intersection of 7 and 4, not the middle of
No.
the 7 meters. and now
No,
7
it's,
meters.
yeah, it's, I really wish this would quit popping up. Yeah, it's halfway on that 14, and then it was shown in the book that the 4 was just, the evenly distributed load was 8 kilonewtons, or 4 meters over from the 8 kilonewtons. Okay? What else? Okay, so then what we've got to do to find the distance, if you look there, we have to take and find the summation of the moments at A, and that's 3 kilonewtons times 5 meters, right?
Negative.
Right? Thank you. Thank you, Clark. Remember, when I say right, usually that means it's not right. Okay? It's a negative 3 kilonewtons, right? Because it is going clockwise, which, unbeknownst to me why, but it's clockwise is negative. I always look at clockwise as time is moving forward, which would be a positive, but not in this realm. Okay? Then we've got negative 8 kilonewtons times about, what did I say there? It was 12, wasn't it? 12 meters. Notice I didn't put any sign in there yet. It is going clockwise again, right? Relative to A. Was it 12? 7 and 5? Remember, it's relative to A. So here's I don't know if I can get our picture in there. Almost. There's our picture. Okay. Then we've got 20, and it's nice that we've got the 28, we've got all three of these forces listed right here. So all we have to do is find the distance, and we're golden. Then we've got 28. Whoa. Oh, I accidentally hit my button there. Meters. So 28 kilonewtons times about 23 meters, and that's also going negative because it's clockwise as well, right? And that's it for now, other than doing the calculation. Now, according to the book, it says that turns out to be a negative 755 kilonewton meters. Is that, somebody punch that in, make sure.
Yeah, that's 55.
Okay, so it's 700, and again, I would write this as 755 kilonewton meters clockwise, because clockwise is negative. Sorry, let me get that up there where you can see a little better. That would be my answer for that. Well, then to find that X bar, if you don't have any questions, if you have any questions, you better speak up. Don't be shy. That's, even though I was shy when I went to school, if you can believe that, I wasn't shy about asking questions. That's what I was here for. Therefore, I expect you to not be shy. Okay? Is there some way I can get this to... Okay, thank you. Wasn't paying attention. All right. Good to go? So, now they're calling that X bar. I didn't label that as X bar. Equals what? It was the moment over the reaction, or the resultant force, right? So it's 755 kilonewton meters over 39 kilonewtons. The kilonewtons cancel out, and you're left with meters. Remember, units are important. And that, according to the book, is 19.4. Since I don't have my calculator, meters. So that translates into this reaction force right here ends up being 755 kilonewton meter. Now wait a minute, I'm sorry, 39. I was going to say that's not right. 39 kilonewtons, and this X bar, if you will, ends up being 19.4 meters from A. That's what they were asking for. Okay, you could calculate it from B if you wanted to. In fact, we could go back and calculate it from, well, I don't know if we could calculate it from B, and it should come out the same amount, but it should be 30 minus 19.4, right? If that slurp shows up on the video, I apologize in advance. I listen to a guy on the radio, he does that constantly. You've probably heard of him, Phil Valentine. He's down in Knoxville, or Nashville, I mean. So let's do it for Robel.
Why did you say you wrote it down as 755 instead of negative again?
Well, it's the negative tells you, and it does come out a negative value, right? I either want the negative value or the CW, but I'd rather have the CW. The negative tells you it's going clockwise, okay? But you don't want to have both of them there. It's almost like a double negative. Just like with a Y value is negative and then the arrow pointing down.
Yeah.
It's a little redundant. Okay, just stretching out. Okay, good. Good questions. Let's see. Let's just do it from B. What the heck? Doesn't cost any more, does it? If you do it from B and you come up with a different answer than the opposite amount there, if you will, then something's wrong. But if we do a sum the moment from B equals, and this is going to require a little different perspective. So if we're looking at it from B, this 28 kilonewtons is making that thing go counterclockwise, right? Which is a positive value, isn't it? And that's part of the reason for doing this too. So we've got 28, there it is, 28 kilonewtons. What's our value there? 7, right? Times 7 meters. Now how do I know that's 7? Well, I know several different ways. One, the difference between 30 and 23 is 7. But remember, this was 14 meters. Excuse me, and we said it was right in the middle. So the distance from here to here has to be 7, doesn't it? Well, then we've got 8 kilonewtons. Oh, now we have to do some math. Well, let's see, 30 minus 12, right? Would be how far 8 is from B. So what's that, 18? And that's making it go counterclockwise as well, so it's a positive. Plus 8 kilonewtons, was it 18? Okay, Clark? Yeah, I didn't put the meters, did I? Yes, sir?
In the book, for that evenly distributed load, they give you 14 meters, and then they give you the 7 meters.
Right. That's just to show you where that new weight will be.
But could we not assume that 7 meters, since it's an evenly did they have to give us that dimension? Wouldn't we know that?
No, they would not. In fact, I would rather they didn't give you that. But that's just what they're doing, is they're saying this is, and I guess for an example problem, that's probably why they do it. For an evenly distributed load, we know it's right in the middle. Yeah, I personally on a test, I will not give you that. I will give you that there are 14 meters and the weight is 2 kilonewtons per meter. End of discussion. There won't be an R on that picture either when I get done with it, because that's what we're looking for. And I think by now you should understand that's what we're looking for. I don't think I should have to put a picture on there for you. Okay? So yeah, let's see, that was 18 meters. Thank you, whoever said that. Then we've got a 3 kilonewton force that looks like it might be about 25 meters from B, right? 30 minus 5. So, and that is going counterclockwise, which is positive. 3 kilonewtons at 25 meters. So we'll scroll down here a little bit more, give us a little more, too much. Okay, and we can do, somebody's gonna have to punch this in for me now.
415.
It should still be, what's the number?
415.
415. Is 415 the total answer? Really? It's not kilonewton meters? Ha! Trick question. But it is kind of pretty important. Well, am I done yet? Counterclockwise. It's a positive value, so it's CCW. So now then, to find the new X bar, if you will, let's say X bar 2, what the heck. It's at 415 kilonewton meters divided by, what was that, wait, 39? Yeah. 39 kilonewtons. They cancel out. What's 415 divided by 39? How much? 10.6. Uh-oh. Is that right? Huh? What was our, let's see, we had 19. Yeah, woo, shoo. So, if we take our X bar 1 we had there, X bar from, let's say from the left, was 19.4, and X bar from the right was 10.6, and that turns out to be 30.0, doesn't it? Phew. We did it right. They did it right. We had to blame them if it was wrong. We're just following the book, right? But that's a great way, if you've got time, to check your work. You can't go wrong. And there again, if you've been doing the practice, you'll have time, because you'll be on top of it. You won't need anything extra. You won't need your book. You know, I said we could use your book. You won't need it. Do the practice problems, you'll fly through this. You know, an hour, let's say an hour into the class you're done, you go home. You get to start your weekend, your 3-day weekend, a little bit quicker. Unless you have another class. You can't, okay. I don't get blamed. Smith said we could go home. I don't want to get blamed. Well, that's a bonus too, right? Good deal. Okay, so are we all squared away on that? And like I said, you can always you can come see me in my office, like Tuesday, Wednesday, Thursday. I've got office hours sometime in there, or you can send me an email. All kinds of different things you can do to get in touch with me. If you're okay.
That's far right, if you go to, that's far right, 10.6 over 40.
30 is the total from A to B. So so good point. So okay, so what I did was 30 is how long that thing is total. If you take it from the left side and get one number, and take it from the right side and get another number, which you should in this case, those two numbers have to meet up. So that's like, here's what, pictorially, here's what we're saying.
X bar right isn't 10.6 over 30. He was adding
No.
left and right together.
Correct. So what we're saying there, whoops, wrong place. What we're saying there, RER, is this distance from here to here is 10.6. Okay? Does that make sense? So that if that distance is 10.6 and the other one's 19.4, they should match up to what that bottom number of 30 is. If they don't, then something went wrong somewhere. Okay? So that's what we're referring to there. Thanks, Clark, and thanks, Harry Har, for asking the question. Appreciate it. Well, now.